All right, guys, today we're going to go ahead and start looking at logarithms and get it, logs, and the different properties that we can apply to them. Hopefully you have already gone through and watched the logarithms explained video because that talks about like what logarithms are and where they come from and why we use them. And so then now at this point we're learning about how to manipulate them and be able to eventually solve equations that contain logarithmic functions. And so the first two properties that we're going to go over are just the first two pieces that are right here. And I think you technically actually already have some stuff written underneath each of these. So basically one of the laws that mathematicians, have discovered and proven as they've worked with logarithms over centuries and centuries of working in mathematics is that anytime you have multiplication inside of a logarithm, and so you have a formula that's already there. If you want to write another example, you're more than welcome to. Um, so anytime you have multiplication inside of a logarithm, so let's say you had log base 4 of, let's say, 2 times v, for example. That's multiplication inside of one logarithm. And technically, you don't have to write this as 2 times v inside of parentheses if it's written like this. That's also assumed that that's inside of a logarithm, but I think that's a little sloppy, so I don't really like that part of it. But so if you have multiplication inside of a logarithm, what you can do is sometimes it's necessary to be able to expand a logarithm into more than one. And so you can rewrite this as log base 4 of just the number 2 plus log base 4 of v. And over here, it's much more acceptable for people to write without parentheses just because there's only one thing that's inside of your logarithm. So if you looked at this, you would say log base 4 of v. And so this is one of the properties for logarithms, and it works both ways. So if you're, you can expand your logarithm, which means you take a single log and you split it up into multiple ones, or you can condense or combine your logarithms. So if I notice that I have addition between two separate logarithms, I could go back this way and condense it into multiplication inside of one logarithm. So that's the first property that we have to be able to work with. The second property is division inside of a logarithm. And so if you had, let's do another logarithm. We're going to do ln, and ln, you just want to write yourself a little note over here. ln is the natural logarithm, which has technically, it has a base of e. But because we use e, which is Euler's number, and natural log, and they pop up so often in nature, it's assumed that if you write ln, you don't necessarily have to write the little e down here, the little base. You absolutely are welcome to if you would like. It's not going to be incorrect, but on even like my worksheets, you'll see that this will just be natural log without anything written there, and that you have to know that that has a base of e. So let's do division inside of a logarithm. So let's say I had, let's do m divided by r. Sure. If you have division inside of a logarithm, then that changes to, one of the ways that I can manipulate that is I can, if I'm expanding it, expand it into the natural log of m minus the natural log of r. And again, this is, you'll see this often without parentheses as well, because now it's just one thing that's inside of your logarithm. And so if you're expanding this into more than one logarithms, you can do that with subtraction outside of the logs. Or if I have more than one logarithm and I want to combine them into a singular expression, subtraction outside of logs turns into division inside of a logarithm. One more thing I did want to note before we move on to practicing some of these is your natural log is one of the common logs that you'll see, logarithms you'll see, and then the other one is when you just see a regular log with no base. This is called your common logarithm. and this has a base of 10 secretly. So those are the only two logs that you'll see without bases. So if you see a regular log, like we could do like log of 14, for example, this has a secret base of 10. And if you saw a natural log of like b, this has a secret base of e. And so you have to be able to know that if there's nothing written there, if it says log, that has a base of 10, and if it says ln for natural logarithm, that has a base of e. Okay. And then I could put numbers or variables in either of these. One of the things that I did want to draw your attention to is the fake log laws. And so one of these things connects really specifically with what we've been practicing on. There are no laws for addition or subtraction inside logarithms. So for example, if you have log base, let's make it base 8 of v plus w, that doesn't simplify to anything. Or if you have natural log of q plus k, or excuse me, I wanted to do a subtraction one. Q minus k, that doesn't simplify to anything. The same way that when I ask you, can you distribute when you have addition or subtraction, you would say no, because there's addition or subtraction happening in that expression. And for a logarithm, it's the same way. Can I simplify this anymore? No, because I have addition or subtraction happening inside of my logarithm. So something like addition or subtraction makes makes the math harder or less simple. Think about it that way. So in this one, in my expression, I have addition or subtraction happening inside of my logarithm, so I can't simplify that anymore. Same way if I had like 2 plus x and I had to square it, if I tried to distribute this exponent, I have to do it the long way or the hard way because I'm not allowed to distribute this because I have addition happening inside of my expression. So make sure that you're not extending these laws to inside of your logarithm, right? Addition and subtraction outside is fine. It's as soon as you get inside inside of a single logarithm, that it's only multiplication and division are allowed to be simplified, okay? So right now what you're going to do is you're going to take a quick IF on just these two properties, and then if you want to move on to the next ones, you're more than welcome to.